Okay, 1.7 is absolute value equations and inequalities. So absolute value is the absolute value of a number x written. The absolute value of x represents the undirected distance from x to 0 on a number line. Okay, so it's the distance, okay, from 0. Okay, so that lends us to, when we solve them, there's going to be two solutions, because the distance from a number, okay, to 0, we can, let's say if we have 0, we have two numbers that are distance 3 from 0. There's 3 and there's -3. Okay, so that's why anytime we're solving these, we're actually going to solve them in two different ways. Okay, so this is the wording, and I'm going to explain this wording as we go. So this is the rules. Okay, and I'm going to leave these up here for you that you can read them later. And as I talk, they will make sense. Okay, so here we go. So the first one is an equal sign. Anytime you see an equal sign, we're going to solve them by splitting them apart. So we're going to do 3x minus 4 equals 11. So we write it the same, okay? And then we write it where the other side is negative. Okay, if you look at some places, they will actually change the left side, which is fine. It works either way. I just go ahead and change the opposite side, or the right side, because I think that's easier to change one number instead of two. Okay, now we're going to solve each equation individually. So I get 3x equals 15, and x is going to be 5 here. And x equals -7/3. Now, how I would write this final answer is squiggly bracket, and that is correct language for math, -7/3 squiggly bracket. Okay, when I'm writing this is telling me these are just dots on a line. Okay, so -7/3 and 5. Okay, they're just two answers. Okay, so that's just equals. Okay, that's how I solve an equals. Now, when I'm solving an inequality, things change, okay? So the big deal here is when I have a greater than sign or a greater than or equal to sign, I need to think of the word or, okay? Greater, okay? So remember, or means union. That's important, okay? So when we do this, we're going to 3x minus 4 is greater than 11. So I wrote it exactly the same. And then I do 3x minus 4. And this next part I say we change the gate. Okay, the gate is the inequality. And then I change the sign. Okay, and then we solve. Now we're going to get the same answers on the right. So I get x is greater than 5. And x is less than -7. Well, or, okay, because it's greater. So let's graph this. So I'm use two different colors here. So I've got -7/3, open circle, less than, and then I've got 5, open circle, greater than. It's an or is a union. That means I take everything, right? So if you want to graph it so you know you're taking everything, you would do -7/3, open circle, and everything's going to be black here. So that means my interval notation, negative infinity to -7/3, parenthesis, union, parenthesis, 5, infinity. And this is my final answer. Okay? So that's important. The sign actually tells us or the inequality sign actually tells us how we're going to write our final answer. Okay. All right. So on this one, less than, or less than or equal to gives us an and inequality. Now, I have notes here that we're going to use a three-part inequality. So a three-part inequality means we're going to do negative 11 is less than 3x minus, I think I changed it to 1 instead of 4, which is fine, is less than 11. Okay, this is still an and. Now, with it being a three-part inequality, that actually triggers us to know that it's an and as well. You could also just separate it and make it an and as well. Just make it like 3x minus 1 is less than 11 and 3x minus 1 is greater than negative 11. It works the same. So plus 1, plus 1, plus 1, negative 10 less than 3x is less than 12. Divide everybody by 3. So I get negative 10 thirds is less than x is less than 4. Okay, but this makes a lot of sense because when I do my graph, okay, then I know it's an and, okay, because I've got negative 10 thirds here, I've got 4 here, and I know that I'm just taking everything in the middle. I don't have to do two different graphs, okay, and so then my answer is negative 10 thirds, comma 4, and I'm done. So whether you choose to do the three-part inequality or you choose to do two parts, the three-part inequality actually makes it a simpler process than what we did before using the inequalities and doing the ands. Okay. All right, so let's solve some here. So less than, it's an and, so let's do a three-part inequality. Negative 20 less than or equal to 20 minus 2x less than or equal to, oh, that's a greater. Ooh, see, I caught myself, y'all. Caught myself. Greater. Or, that's an or. Okay, so 20 minus 2x is greater than or equal to 20, so you keep it the same. And 20 minus 2x is less than or equal to negative 20. So change the gate, change the sign. Let's solve. Subtract 20. Negative 2x. Greater than or equal to 0. Divide by negative 2. X is less than or equal to 0. We divided by a negative. Divide by, or subtract negative 20. Negative 2x. Less than or equal to negative 40. Divide by negative 2. X is greater than or equal to 20. Okay? This is an or. So here we go. So I've got 0, less than or equal to 0, and then greater than or equal to 20. I'm taking it all, right? So if I do it all together, it's all of that. So negative infinity to 0, bracket, union, bracket, 20 to infinity. Okay? All right. So here we go. Now, if we look at B, B's a little bit different. We've added another number on the left side. Okay? So this is a big deal. We've kind of now separated, we've stepped into another realm of problems. Okay? Anytime we add another number on the left side, we have to isolate the absolute value before we split it up, okay? So note, have to isolate absolute value before split. This will cause you to get the wrong answer if you don't do it correctly, okay? All right, so this is an equal, okay? So we're just going to deal with the inequality by itself, right, or the absolute value by itself right now to isolate it. Okay, so I've got Absolute value of 3x plus 2 equals 11. Now that I've isolated it, okay, it's isolated. And when I say isolated, it's all by itself. Now we can split it up. I spelled that all wrong, y'all. I'm going to learn how to spell one day. Y'all get what I'm saying? Okay, here we go. So now we can split it up. 3x plus 2 equals 11. Write it the same. Write it opposite. Okay? Solve. So x equals 3. And x equals negative 13 over 3. Again, it will be written squiggly bracket 3. Oh, it'll be in order. So it'll actually be squiggly bracket negative 13 over 3, comma 3. So smallest number comes first, biggest number comes second. And that's also a My Math Lab thing. You want to make sure you write them in order. Okay? All right, so let's do another one. Again, on the left side, the absolute value is not isolated. We have to isolate the absolute value before we can split it up. Okay? All right, I'm going to like erase everything. So we have more room. Actually, I can't do that because I've got to PDF these notes. So we're going to keep going. Hopefully you're tracking with me. Okay, anyway. So add 3 because we got to isolate. That was a good idea, Mrs. Weddington, until you realize you got to, upload these for everybody. So add 3 to both sides. Now we can split, okay? Once we isolate, we can split. I wish I could make that a song, but I can't, okay? This is one of the biggest mistakes is we forget to isolate, okay? So please, 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 please isolate the absolute value, then you split. Everybody misses that, okay? So now we're going to split x plus 2 greater than or equal to 5. Keep it the same. X plus 2, change the gate, change the sign. Now, I forgot to check. My brain just knew this was an OR because it's a great TOR. So I knew it didn't have to be a three-part inequality, and I could just do 2, okay? So then subtract 2. X is greater than or equal to 3. X is less than or equal to negative 7. Okay? So here we go. Our 2 different colors here. So negative 7, close circle, less than. And then we've got 3, close circle, greater than. Okay, it's an OR. It's great TOR. OR means union. That means I just take it all. Okay, so if I'm going to take it all, my final graph, again, just looks like this. Take it all. So then my interval notation, negative infinity to negative 7, bracket, union, bracket, 3 to infinity. Remember, at infinities, we keep parentheses. Okay? All right. D. Before I split, I have to isolate. So I'm going to add 3 to both sides. Okay? So I get the absolute value of x plus 2 is less than or equal to 5. Okay? Now, this is less than. So that means I'm going to change to a 3-part inequality. So before I can even change to a 3-part inequality, I have to isolate. Okay? So then I get negative 5 less than or equal to x plus 2 less than or equal to 5. Now I can subtract 2 from everybody. I get negative 7 less than or equal to x less than or equal to 3. Remember, the 3-part inequality causes us not to have to do 2 graphs because it's an and it'll just come together because it tells us that x is in between negative 7 and 3. Okay, so we've got negative 7, close circle, 3, close circle, x is between those two. You see how x is already in between? So I just shade in between. And then that just makes our interval notation really easy. Reading from left to right, the train starts at negative 7 with a bracket, comma, 3, bracket. We're done. Okay? Cool. All right. So the next one is if we have absolute values on both, okay? The left and the right. So in order to do that, okay, all we do is we change one of them, okay? So let's solve 4x minus 1. The absolute value of 4x minus 1 equals the absolute value of 3x plus 5. So what we do is we write it the same, and then we write it opposite. But since we're negating a binomial, okay, we have to put parentheses around it. Okay, now we solve. So I'm going to subtract 3x from both sides. X minus 1 equals 5. X equals 6. Okay, and then this one, before I can solve, I have to distribute this. Remember, there's a negative 1 there. So negative 3x minus 5. Add 3x. 7x minus 1 equals negative 5. Add 1. 7x equals negative 4. Divide by 7. X equals negative 4/7. And we again write that as negative 4/7, comma 6 with the squiggly brackets. Okay? All right. Special properties of absolute value. Okay? This is a big deal. Okay? The absolute value of an expression can never be negative. Property 2. Now this property isn't going to make sense, okay? But the absolute value of an expression equals 0 only when the expression equals 0. It's kind of a like, duh, but it just needs to be said. It's just a property, but it'll make sense when we do it. Okay, so we're going to solve these equations. So A, absolute value of 6x plus 7 equals negative 5. Well, absolute value is always positive. Nothing we put in there is ever going to be negative, okay? So, no solution. Okay, nothing. B, absolute value of this number equals 0. So, this is property 2. Okay, and what this is saying is we can't split this up into two different equations. There's only going to be one. So all you do is you just write it once and you solve. So this is 1/4 x equals 3. We multiply by the reciprocal, which is 4/1. So x is 12. Okay, so anytime it's equal to 0, there's only one solution. So that's what that property 2 says. Okay, all right, now let's solve the inequalities. This is when things get a little funky. Okay, so this first one says I have an absolute value, okay, and it's greater than a negative number. Well, let's think about this. Anything I put in here is going to be greater than negative 1, okay, which means this answer is all real numbers, or negative infinity to infinity, okay, because if you think about it, if I try to solve it, I get x is greater than negative 1, okay, or x is less than 1, okay, and then if you put that in a graph, you've got greater than negative 1 and less than 1, and we've seen that before, okay, and it goes through all of them, okay, and I know one time I said that doesn't count, but it counts this time. So we're going with that. Okay? So negative infinity to infinity. Okay. B. So anytime you have extra stuff on the left, you have to solve it first before you can split it up. So here we go. Add 2 to both sides. So the absolute value of x minus 10 is less than or equal to negative 1. Okay. Can absolute value ever be less than or equal to a negative number? No. So, no solution. Okay. B and C are the exact same thing. No solution. I've now mixed them together. I put no solution. No solution. Okay. D. Absolute value of x plus 2 is less than or equal to 0. Well, it can be equal to 0, but it can't be less than or equal. It can't be less than 0. Okay? So, there's only one solution there. And so, it can be -2. But it can't be anything less than that, okay? So that's one where you can say x can equal -2, okay? Because it says equal to, but it can't be anything less than that, okay? That's it.